Welcome to this video on understanding standard deviation. We will explore how to measure the spread in data and discuss why it matters in various fields like quality control, testing, and research. This is the key to understanding data variability. So, what exactly is standard deviation? It's a measure of how spread out data points are from the average, also known as the mean. A low standard deviation indicates that the data points are clustered closely around the mean. Conversely, a high standard deviation suggests that the data points are widely scattered. Let's visualize standard deviation. Imagine two bell curves. The first curve represents a low standard deviation, where the data is tightly packed around the mean. The second curve represents a high standard deviation, where the data is more spread out. The shape of the distribution visually shows how tightly the data clusters around the mean. Now, let's look at the formula for calculating standard deviation. The population standard deviation is represented by the formula sigma equals the square root of the sum of each data point minus the mean, squared, divided by the number of data points. Here, sigma represents the standard deviation, mu represents the mean or average, and n represents the number of data points. Here's a step-by-step guide to calculating standard deviation. First, calculate the mean of all data points. Second, find the deviation of each point from the mean by subtracting the mean from each data point. Third, square each of these deviations and then sum them up. Finally, divide this sum by the total number of data points, n, and then take the square root of the result. Let's go through a simple example. Consider a data set consisting of the numbers 2, 4, 6, 8, and 10. After performing the calculations, we find that the mean is 6, and the standard deviation, represented by sigma, is approximately 2.83. Standard deviation has several practical applications, especially in quality control. In manufacturing, it's used to monitor product consistency and identify defects early in the process. In process control, standard deviation helps in setting acceptable variation limits and triggering alerts when these limits are exceeded. Standard deviation is also invaluable in testing and research. In scientific testing, it is used to measure the reliability of experimental results and data. For research studies, it's essential for assessing variability in samples and populations, ensuring the findings are robust and meaningful. Here's how you can implement standard deviation calculations in Python using the NumPy library. First, import the NumPy library as NP. Then define your dataset. Finally, use the NumPy.std function to calculate the standard deviation. NumPy makes statistical calculations simple and efficient. To summarize, standard deviation quantifies the spread of data around the mean, giving us a measure of its variability. It is an essential tool for ensuring quality control, testing, and research reliability. Master this concept to make data-driven decisions. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.